Today, Robert Myers is going to present about taking the web back with GraphQL. So if everyone could give him a warm welcome.
Thank you. Yes. So we want to get back control of the web from JavaScript. For the past 13 years, I've been a web developer in Python. 6 of those years have been spent at Rackspace. And at this point in my career, I consider myself a senior sanitation engineer. What that means is I don't develop software. I maintain other people's software. And I'm including myself in that other people because I'm sort of a different person than I was a few years ago. I use different tools. I know different things. I have different patterns to solve problems. And I've learned from my mistakes. So no more. So maintenance usually revolves around developers who come and go in your project, sprinkling in little knowledge and taking it with them when they leave. Code that you write usually lives in prod forever and never dies. And if you're unlucky, you have a 5-year-old JavaScript framework that you're using, and it's impossible to update. Maybe you can greenfield, but it is increasingly hard to move from your large legacy code base to another code base. So what we're going to talk about today is changing an existing site. Using GraphQL to create a thin wrapper around your data sources, such as databases, REST APIs, static files, even mainframes. And bring back the business logic that was secretly put into your JavaScript UIs and bring them back to the server. And this will improve testability and hopefully maintenance. So here's an example. We have a little Angular 1.0 application. This is a simple serverless page. It does an API call to fetch the data and renders a table. Pretty simple, basic stuff. But somebody says, well, can you just add the IP address to that list? Which sounds easy. We have the IP addresses on these servers in the details page. How hard could it be? Well, you look at the API call of the servers, and it doesn't have an IP address. And you're like, that's strange. We look at the details page, the code for the details page, and we realize that it's using a completely separate networks API, which takes in the server ID to get back your IP address. OK, well, how can we fix this? Well, we could do a Hacky API solution, which would add a query parameter for include network and sprinkle in the network. And this might work if you own the APIs, but if you don't, or if there are 2 separate teams, or there's different data sources for these, like a different database or different system altogether, it might not be possible to do this. So you could come up with a Hacky UI solution that you could use lazy loading in your pattern, or you could do multiple API calls and join them. But these are all kind of non-standard, and you might already have all of these solutions in place in your old UI code. It gets hard to maintain those, hard to change them, hard to duplicate those patterns. So what can GraphQL do? Your data doesn't fit in neat little buckets. It has relations, some hard and others are soft. And GraphQL helps to separate your data structures from your sources. So what I like to do is practice schema-first design, which is we start with the schema that we want. This is the GraphQL schema. And put in the fields that we want to exist. So for the server, we're going to add in a network field that points to the network type. And then we have our query, which is servers, which returns us a list of servers. Now, to make GraphQL work, we have to wire it together with some resolvers to get that data. And we can use little functions, these asynchronous functions, that you can write them however you want to. They take a source as the first argument and info as the second argument, and the optional keyword arguments. Well, we won't get into that too much. You get the original request in the context of the info, and then you can use that to make your asynchronous requests. And then you'll see the resolved network takes in the server object, which was resolved from this resolved servers, and then it does another API request to get the server's info, or the network info. And these are simple functions that are easy to write, and they're easy to read, and they're easy to test independently of all your base. So anything you can write in Python, you can create a resolver function for. So now to wire it together, this is a little clunky. You load your schema, and then iterate over those fields and add in, for the query fields for the servers, you set the resolver there, and then for the server type fields, you add in the network. There are some libraries out there that make this a little bit better, so don't worry too much about that. But this is just the raw syntax. So now that we have it, we can fire up the GraphQL Playground. It's kind of hard to see, sorry about that. But basically what you're able to do here in the GraphQL Playground is, since the schema is typed, there's a way of doing an introspection query. That this is the first thing that this thing does, is it hit the server, does an introspection query, gets all the types and all the information, all the documentation for it, and allows you to quickly add in the fields that you want, and then execute that query and get back your results. And I guess you can sort of see it, but we have the network info now. So great. That's mostly done. Also, and you can look at the documentation, so you can see what other types are available, and you only get the data back that you ask for. So if you want to query and see what you can go, this is a neat way of going through. This is very, very good for the developer experience. You can also add in Markdown in your schema. At the top there, you see list of servers and connection info. That's a little Markdown documentation that I added to the schema to just show it off. Now, at this point, we have our new API that we can use, GraphQL, and we need to connect it to the UI. One of the main selling points is how easy it is to use, and all you need to do is write these small components that take a query, execute that query, and then iterate over the results, which is okay, but I've written this pattern before, I think in college. Yes, PHP. See, where we connect to a MySQL server, do an SQL query, and then iterate over the results and show a table. Is this the pattern we want to use? Remember, also, we're dealing with an old UI. If you want to pull in a new client, you're just adding in a little bit of technical debt and moving all of this logic into your UI, where it's already complex. We want to reduce the complexity. What if we just cut out the middleman of that, the UI sending the query down to the server, and just rendered it on the server? We can do that just simply by parsing the query and storing it in a variable on the server side. And our request now is just doing the GraphQL request and sending back the JSON results. Now, this endpoint, all you need to do is change your server list page to point at this new API, and you get the network info. Great. So we can apply this to all the other routes. We can say, oh, we got networks, we got the details view, and all these are, they're kind of similar. They're all kind of doing the same thing. So we can refactor this a little bit. We can store all the queries in a folder in these GraphQL files, and then load them for each route. We have the path args of the query that we want to get. So for API GraphQL servers, we'll load the server's query and return those results. So now you only have 2 functions you need to write. Problem is this any better than REST? What we're doing is we're just kind of wrapping it into another bundle of you're tying your resources to a URL. So the way I like to approach it is to think of my UI as a set of views. So, and we can, with GraphQL, you can gather data from multiple sources using just a query. I don't even know what they call it. Writing your query with lots of things. Here's an example. Basically, what we're doing here is we're asking for, we're doing all these queries, and we're keying them with that first argument is the field that's going to come back in the results. So server quota is going to have the quota fields in it. And what you do here is you can ask for all the data that you want for that view in one query and return that all in one result. And so a lot of that data is seemingly static, but so like navigation, for example. You have navigation is mostly static, but a lot of times there's a little bit of business logic in your navigation where different users are going to see a URL. Some users will not, or that URL will not be enabled for them, but you want to display a message for them instead. And you could do that all with this query. And there's also, I've come up with a new concept called resource, which combines 3 separate API calls into one stream. And we can use the type name to display different fields in the query, and the UI can use that to include different components to display them. And another thing you can do with these queries is to set up fragments. You see that ... notation. That allows you to not repeat your queries over and over. You can just have these fields defined. And you'll notice that this query has gotten really large. It's really hard to maintain. It really deserves to be in its own file and separated from your code. That way, it's not tied directly to your UI. It seems like bundling it all in the same source is very complicated. So, oh, my slide's not updating. There we go. Here's the navigation, what I was trying to get at. Navigation is just a simple name tuple, and we create a list of these and return them. And you'll notice that I have not included the enabled field in the name tuple. That is actually done through the resolver. This resolver is going to get the info object, which has the user information, and we can check to see if they have the role to enable this network item, or navigation item. And then we're just adding it to the schema as before. And also, here is my little resources thing that I made up. I'm going to do 3 separate HTTP calls, and then return those with an async IO gather. And at this point, we have 2 options. Now that we have one single query that has all the data for the view, we could just use Jinja templates, which would be 0 JavaScript at all. If your data does not, isn't as dynamic as other, like if it doesn't have to update constantly, then you can easily use this. And you can pick and choose how you want to display it, either using a template or creating a mini SPA. And here is the standard just using a template. We're just going to execute that dashboard query and return the JSON response as a context argument. And for the mini SPA, what we're going to do is we're just going to add a little if statement for a query parameter for XHR. And if that is in the request, we're going to do the GraphQL request and return a JSON response. Otherwise, we're just going to load the template with just the base HTML. And that HTML looks like this, which is pretty simple. It just has a little dashboard component that's going to be loaded. And this is not using NPM or anything like that. It's just, it takes advantage of the type equals module, which is available in Chrome and hopefully in browsers everywhere soon. The future is coming where you can actually write JavaScript with import statements, just like a real programming language without a transpiler. That would be great. So here's our little, my little dashboard view component, which just does on its first load, it's going to do an XHR request and sets the data property. And then it renders the HTML, and it passes the data down to the subcomponents that I've written for my view. So all these components don't need to know about where they get the data. All they need to do is be able to iterate over the data and display it. So you can pick and choose which components you include on your site, and you can also change what data you pass to them to make them a little bit more dynamic for you. And the final results is, here's my little dashboard view that I created, which has a bunch of reusable components. And I have like a table component that I can pass in more attributes or less, depending on what it is, and have some sorting. And then I also have some application action logic, which passes down some form information for me to render. So all the tools you need to do, you need to go up to Python 3.6. That's to get the async I/O. And you have to use GraphQL Core Next, which is slightly different than Graphene. If you've heard of Graphene and Graphene Django, those are written with GraphQL Core, which is a 2.7 compatible version of GraphQL. The GraphQL Core Next is a total rewrite that closely follows the JavaScript implementation, the reference implementation that's written in JavaScript. And it uses async I/O and allows you to do the schema-first design, which I think is really the best way to go. The Graphene Django and Graphene style, where you're actually creating objects and tying those back to your schema, is not as flexible as the schema-first design. One of the main reasons why is because once you write your schema, that GraphQL file can be exported to any other programming language that can read that SDL file. So you could use Node.js if you wanted to, or you could use Go, or Rust, or whatever. But having that flexibility is better than not having that flexibility, I think. And also the way it ties it together with those asynchronous functions, it's a lot cleaner. The logic always usually ends up being easier to maintain because it's not tied to a hard model or to a hard object. I usually use named tuples to define my data types, and then I pass in information to them. And the GraphQL Core Next library, this is just a README for that. Another tool that I've used, Ariadne, is pretty neat. It allows you to do the schema first design approach, and it provides you with little decorators to add in to connect your schema to your resolvers. And it also comes with the GraphQL playground that's built in. So like you saw before, where I showed that you can easily do that with Ariadne. And then there's another library that I started writing before I found Ariadne, called Cannula, which is still kind of alpha, but it has some useful tools, such as some mocking middleware and a profile middleware and a debugging middleware that you can use with the GraphQL Core Next. And I can show you that now because I have a few minutes left. The approach that I've taken to testing is to use HTTP headers to set up my mocks. And I have the Cannula middleware, the mock middleware, which allows you to automatically create mocks based on the schema types in your schema. And here is an example of that header. Kind of hard to read, but we just set the header x mocks objects, and we pass it a JSON string of things we want to replace in our schema. So for every string type in my schema, I'm going to return a fake string. And you can do this with any of your custom types as well. And to set up the middleware, there's a couple ways. You could do the header approach. You can also do pass mock objects, which is just a dictionary of the fields that you want to replace, such as a query. You can replace the whole query with a response, a mocked objects, or you could selectively go in and pick and choose what you want to mock out. And the great thing about this is you're not mocking out the entire response. You're only mocking out the resolver portion, and you could get it down to one specific resolver type. And that allows you to do some fancy stuff that we'll look at a little bit later. Here is basically roughly how the mock middleware works. It has this resolve function, which takes one extra argument than a normal resolve function, which is the next, and that is the next resolver in the chain to run. So if you don't resolve anything, you should call next. And this just takes in it looks for the field type and the return type and gets the schema type that you're asking for and checks to see if there's any mocks registered for it and returns that. So what you can do in your end-to-end tests is set up mocks through headers. So this is using Cypress. You'll see in the test setup, I have for all requests, I'm going to set the x mocks header to this mock resource, and then I'm just going to call that resource URL, and that passes the mocks down to the GraphQL server, which responds with that fake object, which is slightly different than mocking out the entire response, because you're not. If you mock out the response, then you're stopping at the test layer. This actually runs through all of your UI code and all of your server code down to the GraphQL portion where it hits the middleware, and then returns that response. So it's almost a true end-to-end test, or it's as if you're going into the database underneath and mocking that out, and then performing your end-to-end test. The beauty of that is you can set this up. You can actually run it in production if you wanted to, I guess. But you wouldn't have to. You don't have to get in and underneath and change anything. So that's about all I have. Here's some links to all of the technology that I used. Cannula, Ariadne, and GraphQL Core Next. So I guess we could take questions if we have any.
So we've got some time for questions. If you do have a question, please step up to the mic. I'm going to ask that you please state your question in the form of a question, just one question. Thank you.
This is okay. Hi, Robert. Thanks for the presentation. This is really great, and I plan to use a lot of it. The question I have is, like, how do you handle situations where the UI is complicated enough that you really need like a designer to be manipulating a lot of those JSON objects, right? So for me, I'm a backend developer. I write APIs.
Mm-hmm.
I have talented designers that usually take those JSON objects and manipulate them with a lot of JavaScript and CS stuff to get it to look the way I want. And I can imagine them balking at providing them HTML snippets because what you demonstrated wasn't so clean. How do you get around that negotiation?
Well, so I guess the way I was using it, the web components that I used, you could use any web framework you wanted to. I was just showing using web components because they're kind of the new fancy thing to use. But if your UI designers, they use React or Angular 1.0, they could continue to use that, use whatever they want. They're just going to get the JSON payload with all the data that they have. The main reason why I like this approach is that you divorce the UI from knowing where the data comes from, because you can just say, just hit the parent view, hit the same URL, fetch the data, and then display the results. Does that make sense?
It does. I'm just limited to one question, so I'll try to follow up with you.
Okay.
Does it work? Oh, okay. So I have a kind of a naive question a little bit. There are a lot of debates on the internet about what is better GraphQL or RESTful APIs, and you gave one of the examples of kind of mixed APIs when you control one API, the other one is not control or something. But let's say I want to start a new project and I know that I'm going to control my API. Why should I use GraphQL?
If you're going to be the only consumer of that API, then you might not need GraphQL.
That's what I thought.
It depends. If you want to do the client-side stuff and put it all in JavaScript, then GraphQL is the way to go and use the Apollo client. But I think it's way more complex than you need.
Right.
That's my opinion.
Yeah.
Time for one more short question.
Hi there. I was hoping you could speak a little bit to if you have some experience working with Apollo, and particularly Apollo 2, and how they're trying to move away from having you use Redux to manage your state on the front end.
Yeah, so that's one of the main reasons why I dislike using the Apollo client, is because they've transitioned from one way of doing things to another completely different way of doing things, and that is out of your control, right? If you give up all of your UI logic to some third-party tool, they control how it works, the interstate. So the way I've been doing it has been removing the Apollo client, because that's where we started. We started with Apollo Server, started working. It was great, worked with React. Some things worked, and it worked with React and Redux, and it was, but then they've changed, and now we can't update. So we're stuck with a lot of legacy code. So ripping all of that out and just replacing it with just JSON, which works with all frameworks.
Thank you.
Please give our speaker a round of applause. Thank you.